Okay, moving right along. Once we've done simplification for these rational expressions, this sort of reducing to lowest terms, the next stage is to look at multiplication and division. And in the same way that sort of simplifying essentially was kind of equivalent to reducing to lowest terms, multiplication and division is just going to follow our usual fraction, multiplication, and division setups. We're going to do essentially the same thing we would do for fractions. So that means, right, if I've got, a over b times c over d, I'm essentially just multiplying the top two together and the bottom two together. If I'm going to do a division, right, a over b divide by c over d, we do this sort of keep change flip is how it's sort of sometimes explained, where you're going to keep the first one the same, keep the first fraction the same. You change your operation from division to multiplication, right? Multiplication and division are kind of the same operation forwards and backwards. So if we flip from the division side to the multiplication side, that's okay, as long as we then also kind of flip and change our fraction. So we're going to flip the operation, rather change the operation, and we're going to flip the second fraction. So rather than c over d, it'll be times d over c. So these would kind of be our normal setups. Now the other thing here, right, is when you do this, for fractions, the recommendation is don't just multiply and get bigger numbers, because then you have to reduce to lowest terms. So the real move here is going to be to sort of factor everything out first and then look to cancel and reduce before you multiply. And just like with fractions, so for example, right, if I had, 25 over 27 times, 12 over 20 or something, right? The whole idea here with fractions would be to say, well, 25 is like a 5 times 5, 27 is like a 3 times 9, 12 is like a 3 times 4, 20 would be like a 4 times 5, and the whole move is you say, okay, so I have a bunch of values in common. So one up top and one on the bottom, and going on the diagonal or sort of top to bottom, those guys will cancel. So 3 for 3, 4 for 4, 5 for 5, leaves me with, in the end, in this case, just a 5 over 9, essentially times 1 over 1, which would just be 5 over 9. So that same kind of process that we would do for a fraction, right, kind of factoring it out and looking for any sort of common factors to sort of cancel away, we're going to do that exact same thing here for our rational expressions. So let's kind of keep that in mind, and let's see what we've got. So how about, let's do x plus 6 for x squared minus 1 times x squared plus 5x plus 4 for x squared plus 6x. So a couple things. What's the order we should do this? I tell you what, let's look at the two denominators first, just like we did in the simplification ones. So restrictions still in play. Restrictions still a thing, not a things, but a thing. So our denominator is not allowed to be 0. And in this case, now there are sort of two separate fractions, and each of them has a denominator. So let's deal with both of those things first. Again, I think just doing the restriction just right off the bat is a good move. You're going to do your factoring that you would do anyway. And honestly, it's just easy to forget if you kind of don't do it first thing. So what are these guys going to be? X squared minus 1 is not allowed to be 0. This is our nice difference of squares, right? So that's going to be kind of an x plus 1, and an x minus 1 is not equal to 0. And my hope is at this point you're probably used to saying, okay, so this means, right, you're kind of getting the opposite number here. So this means x cannot be -1. This means x cannot be +1. That's kind of restriction 1 and restriction 2. The second one here is interesting, right? Because this is not really one that's not a difference of squares. It doesn't have three terms, right? Are sort of quadratics with the a and the b and the c terms. This is just two terms, so the best we could do here, x squared plus 6x not equal to 0. What you can do as far as factoring is you can take an x out of both terms, right? So you can do sort of 1x in front. You're going to get then an x plus 6. That obviously would mean that x is not allowed to be negative 6. And the thing here is that the x in front just means directly that x itself cannot be 0, right? So a single x in front, if this is, right, x squared plus 6x, x is in both places. If the x is 0, both of those would be 0, and it would make the whole thing 0. So factored out, you kind of get it isolated. It sort of tells you very distinctly the x cannot be 0, and it also cannot be negative 6. So that's both of our denominators factored. Let's maybe sort of take this numerator out here. Let's just go ahead and factor this while we're working on this. X squared plus 5x plus 4. A is 1, right? B is 5. C is 4. If you weren't, feeling super confident about your factoring from P5, well, have no fear. You're going to get a lot of opportunities to sort of practice and hone this skill. This factoring stuff is here to stay, in a way that few math a lot of math stuff you learn and it sticks around. Factoring for us in this class in algebra and beyond is really going to stick. We're going to see this a lot. So A is 1. That means I have my sort of nice kind of best case scenario. A times C, 1 times 4 is positive 4. I need to sum to 5. This one, pretty obvious, would be, right, positive 1 and 4. Positive and positive, 1 and 4 would get us there. So that means the factoring here should be x plus 1 times x plus 4. What's the last one? X plus 6 doesn't really need to be factored, right? That one just kind of is what it is. It's simple enough. So let's rewrite this, factored out. We're going to take note, right? We have these different restrictions here. We just need to sort of note them. So this would be x plus 6. So over the factored version, so that's x plus 1 times x minus 1, right, from here. The numerator, right, up top, x plus 1, and then times x plus 4 over, what's our denominator? X squared plus 6x. So that was kind of single x times x plus 6. And you can start to see this is, right, one of the things here, to a certain extent, if this is a homework problem, right, a problem from the book, a problem from a quiz or something, probably there's overlap. If we just sort of pulled, numbers and terms out of a hat, we wouldn't be guaranteed to have any real overlap here at all. But just to make this an interesting problem, probably there's overlap. So you can kind of expect to see that. The one thing I'll do here, right, is x plus 6, this kind of single term. Let's put the parentheses around there. That just helps to sort of, helps us to see a little bit better what can cancel. So in this case, the x plus 1 goes, and then the x plus 6, right? So we're kind of going on the diagonal here, which is totally fine. We would be left with what? So this would be kind of x plus 4 up top, and then x minus 1 times x. That's fine. There's nothing there that's really going to multiply out or sort of cancel anymore, so you can kind of just leave it. So this would actually be our final version. The only thing I would say is sometimes you'll see this bottom one written flipped around. So rather, right, x plus 4, and then if you have the single x, a lot of times you'll see that shifted in front. So x plus 4, and then x times x minus 1. And so that was where all of our restrictions, x is not allowed to be negative 1, positive 1, 0, or minus 6. Now, one thing I'll sort of say here is you might say, well, what's the problem with minus 6? Because here, it looks like the only issues that we really have, right, because some of these things canceled out, would be 0 and positive 1. So why are we still excluding negative 1 and negative 6? Aren't those kind of like free to work again? Shouldn't those be like kind of back on the menu? And the answer there is no, not quite. The restrictions are always based on the original version, right? Whatever your sort of initial setup was with all the parts before it's been simplified and factored and cleaned up. The restrictions are always based on that original version. So we're going to keep all 4 of the restrictions that we had from before we did any cancellation. That's another reason why you want to kind of do these restrictions early, do them before you really get everything factored and start to cancel stuff out, because if you cancel stuff out from the bottom and then you don't go back and find a restriction based on it, you're going to be, you know, ending up with something that is wrong in a minor way, yes, but technically wrong. It's certainly wrong on the homework, and of course that can be really frustrating. So make sure you find all those restrictions first before you do any cancellations. Even, right, when things cancel, they still need to be accounted for in the restrictions, because it's based on this sort of pre-factored and sort of pre-canceled version, the original version. That took a good chunk of time. I'm going to stop this video and we'll do a second example that covers division in the next video.